Hi everyone, this is Praveen, and if you are someone new to this YouTube channel, then don't forget to hit the subscribe button. Today in this video, we're gonna discuss about Geeks for Geeks problem of the day. Today's date is 12th of August 2025. Before diving into the session, if you are someone really new to this YouTube channel, then please consider subscribing my channel and leave some comments. Let's dive into the video. Today's question is shop in candy store, and the date is 12th August 2025. This question is classified as a medium difficulty level question, and it's a array based question. Let's try to read it. In a candy store, there are different types of candies available, and prices of I represents the price of ith types of candies. You are now provided with an attractive offer. For every candy you buy from the store, you can get up to K other different candies for free. Find the minimum and the maximum amount of money needed to buy all these candies. This question might look easier for someone who is familiar with coding, but try to understand the question. These kind of question most probably you get in your coding round interviews, and you have to explain this carefully to the interviewer. Let's dive into the test cases. The first test case is the prices array represents the different types of candies with respect to their price. You can see the zeroth type of candy cost me 3 rupees, and the first type of candy cost me 2 rupees, and this one cost me 1 rupees, and the last one cost me 4 rupees. Now the question is, wait a minute, let me move to the whiteboard. Okay, let me write down the array. Here you can see 3 2 1 4. So basically 3 2 1 4. We have to find the minimum cost required to collect all these candies. We have to find both minimum and maximum amount required, but let's try to find the minimum one first. If you find the minimum now, it's basically the logic is vice versa to reveal the maximum cost. Okay, let's try to work on solving the minimum cost required to collect all these candies. The step one, I would try to find the candy which is the cheapest one or more cheaper. Here, one is the cheapest candy while comparing others. So I purchase this one. I'm going to purchase this one, and for this test case, I'm so sorry, I forgot to write down the case value. Here k equal to 2. So I get 2 candies for free. For every single candy I purchase, I get 2 more candies for free. So I purchase this one, and I get this one and then this one for free. Why I am marking these two is because it costs me more price. It's basically costlier. So I have to pay for the candies which is cheaper, and I'm trying to get the costlier candies for free. I purchased this one, which is the cheapest one in this candy set, and I get 2 candies for free, which are the most costlier one while comparing others. And you see, still now in the step one, I have collected. This is step one. I have collected so far 3 candies only. For one candy, I paid its amount, and I got 2 more candies for free. But still, we have to acquire this one. We have to collect this one also. So once again, I'm going to make a purchase. this time I'm going to buy this candy. Okay, now I purchased this one also, and the offer is still applicable, so I can get two more candies. I try to get this one, but this is already sold, which means it doesn't exist. It doesn't even exist in this particular step, and no such candies exist actually. The list is empty if you purchase this now. So we acquire all the candies with this approach. Hey, Praveen, you are so confusing me. It looked like you were saying cheaper, costlier, minimum. What do you try to mean by that? It's basically like we are given a array, we have to find the minimum amount required to collect all the candies. So my approach is we are trying to purchase the candies which are cheaper, and we would get the costlier candies for free with that attractive offer. I purchased this one, which is the most cheaper one, and I get these two for free. Both of them, I mean, these candies are most costlier when comparing others. And we collected three candies only with this purchase, and still we have to collect this one. I purchased this one. I get two more candies for free, but there is no such candy exist itself. In the second step, you have to collect this candy, and the store only contains this candy only. The store contains this one only. The store contains this one. So you purchase this and you pay the amount and you get it. No more fee. The offer is not applicable. That's it. And for this, what I'm going to do is I would sort this array. Just try to figure out the pattern. We have to sort this array in order to get the cheaper elements at the front and the costlier element at last. So wait a minute, hold on. Okay, now I'm gonna sort it out. Actually, with bare eyes we can see which one is cheaper, which one is costly, but machines don't really work that way. For that we have to sort this array. The original array is 3214 and the sorted array is 1234. In the first step, the cost is 0. I am trying to figure out the minimum amount required to collect all these candies. In the first step, I am going to buy this one since it is the cheaper, it is the most cheaper while comparing others. I pay for this, so the cost plus equal to price of 0. You have to make the purchase individually. We have to purchase each chocolate, each candy individually. Okay, Praveen, you made the purchase. You purchased this one, and I get a offer to get K candies for free. As we discussed earlier, for this test case, the K's value equal to 2. So I can choose any two. Apart from this one, I can choose any two to get for free, and I choose these two because it's simple. It's so costlier when comparing others. I get these two candies for free, so the pointer is now reduced to 2, or the candies count. I mean the collected. C refers to the cost and collect refers to the collected candies, and I just add collected plus equal to 1 since we have to necessarily purchase at least one candy to get K candies for free. That's it. And in the second step, okay, just a second. We already bought this one and got these two for free. So the candy store would have only this candy only. No more candies exist. In the next step, I have a array which only consists two, only one candy. So the cost is I have to collect this, which is 2. The cost is 2. The cost is 2 rupees, and here in the step 1 itself we already paid 1 rupees. In this step, C gets increased to 1 since we made a transaction of 1 rupees to get 2 candies which cost 3 rupees and 4 rupees respectively. And that's it. With this approach, we can collect all the candies and figure out the minimum amount required to collect all those candies. Let's move to the next part. We have to determine the maximum amount required to collect all those candies. It's basically the vice versa of this logic. So what I'm going to do is same. The sorted array, the sorted array 1, 2, 3, 4. I purchase this one and get this 2 for free. Since I have to find the maximum amount required, I am targeting the costlier one to purchase and get the cheaper one for free. Here in the step 1, I am purchasing this and getting these two for free. Sorry, I am getting these two for free. I don't have a pen with me, that's the issue. I'm using a mouse to draw all these. So I basically collected this one, this one, this one. The cost is 4. Initially, we started with a cost of 0 and I added this one to our cost, which is 4. Let's move to the next step. It's step 1, and the step 2 is and the step 2 is and the step 2 is we have only one element remaining and I have to purchase this. So the cost plus equal to 3, so the cost equal to 7. Here you can see the minimum cost required to buy all these candies is 3 and the maximum cost required to collect all these candies is 7. Same applicable for this one also. In this array, I mean in this particular shop, if you purchase one candy, then you get 4 candies for free. And the store itself contains only 5 candies, not more than 5, exactly 5. So what you or me going to do is just buy the most cheaper one and get the remaining for free. So Here the most remaining one is, sorry, I mean most cheaper one is 1. I purchased the candy which cost around 1 rupees. I made a purchase and I collect all the remaining candies for free since the count is less than or equal to the count of the shop. The shop provides that particular offer, like it's like a 4. For every candy I purchase, I get 4 candies for free. So I purchased this one and get all the remaining one for free since it's less than or equal to 4. So it only requires me for 1 rupees to collect all these candy. While considering about the maximum amount required, I purchased this one since it's the most costlier one and I get the remaining candies for free. That's it. The code is it's the code. I'm using two-pointer approach to solve this problem, and this code provides more readability than using a for loop. Here you can clearly understand I'm initially assuming the cost is equal to 0, pointer equal to 0. Len indicates the length of the array prices and count equal to 0, while pointer less than 1 and count less than len, which means I try to collect this one, this one, this one, this one, and as long as I have a remaining candies in that shop, I'm trying to continue my purchase. If I collect all the candies from that shop now, I'm exiting. That's it. And I add it to the array list, and now I have to figure out the maximum amount required to collect all those candies. For that, I am making the purchase from the reverse order of the array. I am purchasing the candies which are more costlier than others, and I am getting the cheaper candies for free. For that, I am assigning the pointer to the rightmost element. And for each transaction I make, I get k number of candies for free. You can see that one here. I will pointer greater than or equal to 0, count less than len, cost plus equal to prices of pointer, and count plus equal to 1 plus k, pointer minus minus. That's it. At last, I am adding that maximum amount required to the array list and I am returning the list. That's it. The time complexity for this code is O of 1, O of n, and the space complexity is O of 1. Some might say it's actually a O of n. No, it doesn't. We're gonna use only fixed size of variables. For sure, we know the array list won't go beyond the size of 2. So the time complexity is O of n. The space complexity is O of 1, which is quite good to interest your interviewer. But if you further need a optimal approach, na, you may see some other YouTube channels or refer AIs. What my purpose is to bring a simple code to this YouTube channel so that everyone gets understand the logics. And yes, as I mentioned earlier, I won't primarily focus on the technical coding session. Instead, I want to make sure you all understand the logic, understanding the problem as well as understanding the logic to solve this problem. That's it. Let me run this code. I have already solved this problem today morning itself. I know for sure it would be clearing all those test cases. Yes, it did. It passed all the test cases and the time taken is 1.02. It's good, but it could be improved. Okay, thanks for the video, or thanks for watching this video. If you really feel it's worth the time, then drop me a comment. Thank you. See you in the next video. Bye.